In this video, we're going to be looking at graphing translations of simple rational functions. So we're going to be looking at graphing functions of the form y is equal to a over x minus h plus k. And so remember, this minus h, that is telling us that how much the graph shifts to the left or right. And that k tells us up and down, just like we've seen with transformations and all of our other functions. So to graph a rational function of this form, we're first going to draw our asymptotes. And our asymptotes now, instead of being x equals 0 and y equals 0, since it's translated, it's going to be x equals h and y equals k. And be careful with this x equals h. Remember, it's always going to be the opposite sign of what you see here. And so since it's of the form x minus h, if this were x minus 2, that means my h is equal to 2. However, if this was x plus 2, then h is going to equal to negative 2. And then our horizontal is going to be y is equal to k. So we're going to draw those first. And then our next two steps are the same as before. We're going to plot points to the left and right of the vertical asymptote. And then we're going to draw the two branches. So looking at this first example, I have f of x is equal to negative 4 over x plus 2 minus 1. So my first step is I want to determine what my asymptotes are. And so I see here that I have x plus 2. So my 2 in some form is going to be my h, and minus 1 is my k. For my h, remember, I need to take the opposite sign I see here. So since this is x plus 2 in here, x is going to equal to negative 2. And the reason why is we're looking to see what makes that denominator equal to 0. When I plug in x equals negative 2 into that denominator, negative 2 plus 2 gets me 0. And that's my undefined. And then my k is equal to negative 1, so that means that my vertical or my horizontal asymptote is negative 1. So now I'm going to go ahead and draw that on my graph because I know I'm going to be following that when I am drawing my branches. So first I want to graph x equals negative 2. Remember, with x equals some number, that line is a vertical line. So I want to go to negative 2 on the x-axis and draw a dashed vertical line. And then I want to go to y equals negative 1 on the y-axis and draw a horizontal line. And so now I can go ahead and determine some points on the left and right. So I'm going to pick x values to the left of x equals negative 2 and to the right of x equals negative 2. So you can choose these strategically so that you get a whole number. So first I see if I plug in negative 6, I get 4 on the bottom, and negative 4 is can be divided by 4. So I'm going to choose negative 6, and then I can choose negative 4 and negative 3. And then to the right of x equals negative 2, I'm going to choose negative 1, 0, and 2. It's okay if you choose different numbers as long as you have some numbers to the left of negative 2 and then to the right of negative 2. So plugging in negative 6 into this function, I have negative 4 over negative 6 plus 2 minus 1. And when I plug that in, I get 0. When I plug in negative 4, doing that same process, I get 1. Plug in negative 3, and you should get 3. Plug in negative 1, you get negative 5. Plug in 0, and you get negative 3. And then when you plug in 2, you should get negative 2. You don't have to do all this by hand. You could put this into Desmos, and it will calculate out what that value is for you. And I'm going to go ahead and plot these points. So I have negative 6, 0, negative 4, 1, and then negative 3, 3. And so that is my one branch. So now I'm going to follow these dashed lines. So I'm going to go along it, but not cross it for my first branch. And then I have negative 1, negative 5, 0, I actually did 1, negative 3. Okay. 1, negative 5, negative 1, negative 5. 1, 2, 3, 4, 5. Yeah, that's right. 0, negative 3. And then 2, negative 2. So I'm going to follow along my asymptote, but I'm not going to cross it. And so this is my graph. And so we see that this graph is a translation 2 units left and 1 unit down of the function f of x is equal to negative 4 over x. Okay, let's look at one more. So now I have f of x is equal to 3 over x minus 2. My first step is to determine my asymptotes. So first I look to see what my h is. I see I just have an x here, so I can kind of think of this as being 3 over x plus 0. So that means that 0 is my h. So I have x is equal to 0 for my vertical asymptote. And then my k is negative 2. So that means that my horizontal asymptote is y is equal to negative 2. And so I'm drawing in, I have x equals 0. So just basically the y-axis. And then y equals negative 2 is a horizontal line through y at negative 2. And then now I can go ahead and figure out some points. So I want to pick 3 points to the left and right of my vertical asymptote. So my vertical asymptote's at 0. So 3 points to the left, I can choose negative 3, negative 2, negative 1. And then 3 points to the right, I can choose 1, 2, and 3. So plugging in negative 3, I have 3 divided by negative 3 minus 2, and I get negative 3. Plugging in negative 2, I have 3 divided by negative 2 minus 2, which gets me negative 3.5. And then following that same thing, when you plug in negative 1, you get negative 5. When you plug in 1, you get 1. 2, you get negative 0.5. And then 3, you get negative 1. So applying those points, I have negative 3, negative 3. So 1, 2, 3, 1, 2, 3. Negative 2, negative 3.5. And then negative 1, negative 5. So drawing this branch, I'm going to follow along my asymptote, but I'm not going to cross it. And then for my second branch, I have 1, 1, 2, negative 0.5, and then 3, negative 1. So I'm going to follow my asymptote, but I'm not going to cross it. And then for both of these, it did say to state the domain and range. So looking at this first one, remember with domain and range, it is all the values that x can be for domain and all the values that y can be for the range. And so for both of these, it really can be any value except for where those asymptotes are because it doesn't cross it. And so that means for the domain on this first one, x cannot equal negative 2 because my vertical asymptote's at negative 2. I see both of these graphs do not cross that. And then for range, y cannot equal negative 1. So same thing over here. The domain is just going to be that x cannot equal to 0 where my vertical asymptote is. And then for the range, y cannot equal negative 2 where my horizontal asymptote is.